we do have the sequence an equals 1 over 3 brackets and whole to the power of n, where n belongs to the set of positive integers. We need to show that an, the sequence, belongs to a little L1 space, which is the space of absolute summable functions, summable sequences, and a little L2 is the space of square summable sequences. I will write them here. An such that the sum from n equals 0 to infinity of the absolute value of an is bounded, is a finite number. When you get the sum from n to 0, from 0 to infinity of the absolute value of the terms in the sequence, then this is less than infinity. And little L2, you have a sequence an such that when you take the sum from 0 to infinity of an squared, this remains a bounded quantity. So let's take the sum from n0 to infinity of absolute value of an, that is equal to n0 to infinity, the sum, 1 over 3 to the power of n, absolute value. I can remove the absolute value here. The sum from n equals 0 to infinity of 1 over 3 to the power of n. That's an infinite series. That gives me 1 over 1 minus a third. That's 3 over 2, which is less than plus infinity. Which means that my an, the sequence an, belongs to the little l space of absolute summable sequence, L1 of I, and an. Now we take the sum from n equals 0 to infinity of an absolute value squared. That's a third to the power of n, and that to the power of 2. We can use the laws of indices. This is going to be sum from n equals 0 to infinity of a third to the power of 2n. And this can be written as the sum from n equals 0 to infinity of 1 over 3 to the power of 2 and to the power of n. And that equals, this one is 1 over 9 to the power of n, is an infinite geometric series, and the r is less than 1, is 1 over 9. And so it's 1 over 1 minus 1 over 9, 9/8. It's 9 over 8, which is a finite quantity. And thus we conclude that it belongs to the little L2. So conclusion is that an belongs to the little L2 space, and the counting measure is the interval where we have the positive whole numbers starting from 0 up to infinity. So an belongs to the space of absolute summable sequences, little L1, and an belongs to the square summable to the space of square summable sequences. What else can we do here? I think these are two important applications. Of course, you can have L3. You can have L3, little L3 of I, an, such that the sum from n equals 0 to infinity of an to the power of 3 is a bounded quantity. We can just have a look at this calculation. That's 1 over 3 to the power of n and all to the power of 3. From the loss of indices, that's a third to the power of 3n. And that is a third to the power of 3 and the whole thing to the power of n. That's 1 over 3 to the power of 3 is 27. And this will give me 1 over 1 minus 1 over 27. Which is 27 over 26, and it's clearly less than infinity. And you can do the same calculation for the L4. You take the sum from n equals 0 to infinity of an to the power of 4. That's the sum from n equals 0 to infinity of a third to the power of n and all to the power of 4. By using the index laws, that is 1 to the power 1 over 3 to the power of 4, and the whole thing is to the power of n. 3 to the power of 4 is 81. One over 81 to the power of n. It's an infinite geometric series. That's 81 over 80 is less than infinity, and that means that an belongs to little L4 space. And here an, the sequence, belongs to little L3 space. It's good to know that when we have a sequence, we can see if we can if it belongs to a class of sequences by doing these calculations. Now, if you take an and you take a subsequence, so an is a third to the power of n. An is a subsequence. So instead of n, I put a third to the power of n. An equals a third, and that's a third to the power of n. So that is a third, and that's 3 to the power of minus n. And here I can write 3 to the power of minus 1, and here 3 to the power of minus n. That's 3 to the power of minus 3 to the power of minus n. And here I can write 1 over 3 to the power of 3 to the power of minus n. That's if you want to find a subsequence. You can do that trick. You can check if the subsequence belongs to these spaces as well. It can be a little exercise.